This is an introduction to the Nitro cell. The Nitro cell is something which is closely related to a Joe cell, and the way that it operates is most unusual. It operates to enable internal combustion engines to run on fuel which is not necessarily provided by the user. This document describes a system which uses water and air as the primary fuels, but does not use electrolysis to generate HHO gas for use in the engine. Instead, the objective is to create a continuous supply of nitrogen hydroxide, that is NHO2, for use as the fuel. This system has worked well for a number of people, but there has been considerable intimidation, and most of these people are very reluctant to pass the information on. This document is an attempt to present those details clearly enough to allow the system to be replicated by anyone who wishes to do so. So, how exactly is this fuel generated? The production method is described as the fuel gas being synthesized by a mixture of steam, water and rock salt, that's the mineral halite, in the presence of air, being acted on by engine vacuum electrolysis and a strong magnetic field. This fuel is said to be more powerful than hydrogen and is a much more viable fuel source, as less of it is needed to run an internal combustion engine. This system may be used with any internal combustion engine, whether in a vehicle or stationary, when powering, say, an electrical generator or other equipment. The additional equipment consists of one, or possibly two, horizontal cylinders mounted near the engine. A single horizontally mounted cylinder can generate sufficient gas to power an internal combustion engine up to 2 liters in capacity. Larger engines will need 2 cylinders to generate enough gas for them to operate. It must be stressed that this is not an HHO gas electrolysis cell. One test vehicle has been run on this system for a distance of 3,000 miles, that's 4,800 kilometers, and the liquid fuel used was only 2 liters of water and 2 gallons of petrol. 2 liters of water converted to HHO gas will definitely not power a vehicle engine for anything like 3,000 miles. So let me stress again that the fuel being generated in this cell is nitrogen hydroxide, NHO2. The person using the system which is shown in the following photograph has opted for an exceptionally long generation tube, which is running alongside the engine in the construction there. This is a stationary standby generator which is mounted in a custom steel frame. The versions of this cell design shown in this previous photograph and in the following photograph are early models which were in use before it was discovered that there was a considerable enhancement in gas production if a coil is wrapped around the cylinder. For vehicle operation, it's more normal to have a shorter cylinder or pair of cylinders if the engine capacity is large, as can be seen in the following photograph of a 4-liter 8-cylinder vehicle engine which uses this system. There are the 2 fairly short cells, though admittedly, as he points out, that there is no surrounding magnetic coil, which we will go into shortly here. The construction details are not difficult to follow, and the materials needed are not particularly difficult to find nor expensive to buy. The main body of this device is constructed as shown in the following diagram. A chamber is constructed from a piece of 316L grade, that's food quality, stainless steel pipe, 300 millimeters or 12 inches long, and 100 millimeters or 4 inches in diameter. The length of 300 millimeters is chosen for convenience of fitting in the engine compartment of a vehicle. If there's plenty of room there, the length can be extended for better gas performance and greater water capacity. If that is done, keep the 100 millimeter cylinder diameter and all the clearance dimensions mentioned below for the shorter version. The chamber is sealed at each end with 12 millimeter, that is half-inch thick discs made from Lexan. Lexan is a very strong polycarbonate resin thermoplastic. These discs have a 3 millimeter, that is a 1/8 of an inch deep groove cut into their inner faces. The groove is there for the cylinder to fit into when the discs are clamped in place and held by stainless steel nuts tightened on a 10 millimeter stainless steel threaded rod. To combat engine vibration, a lock nut is used to clamp each of the retaining nuts in place. There's one retaining nut at each end of the 10 millimeter threaded rod. Let me stress again that the threaded rod is stainless steel. It's not an iron version threaded rod plated with zinc. It has to be a stainless steel threaded rod. The threaded rod also provides the contact point for the negative side of the electrical supply. So the minus of the battery is connected through the rod itself, and the threaded rod forms an electrode in this particular device. The positive side of the battery supply is connected to a stainless steel bolt which is TIG welded to the outside of the cylinder, and that forms the connection point for the positive side of the electrical supply. So this is a cross section through a typical Nitro cell as such. It's not complete, this diagram, but it is the first and major step in making one. Looking at the end, you'll see the Lexan disc, the threaded rod, the connector for the battery minus, which is a solder tag, and the locking bolt, which is holding the main clamping bolt tight. That's the end view of the particular cell that's been demonstrated. This basic container is modified in a number of ways. Firstly, a small 3 millimeter or 1/8 inch diameter air intake pipe is provided in one of the Lexan discs. This is an air intake with a needle valve mounted in it. The needle valve is screwed tightly shut for the early stages of testing, and it's only eased slightly open when the engine is actually running. Also fitted is a 12 millimeter or half-inch stainless steel pipe attached to the stainless steel cylinder to form a gas supply feed to the engine, and a one-way valve is placed in that pipe because the design calls for the cylinder to be maintained at a pressure which is less than that of the outside atmosphere. The lower the pressure inside the cell, the greater the rate of gas production. The one-way valve allows flow into the engine, but blocks any flow from the engine into the cylinder. This valve is the same type as is used in the vehicle's vacuum brake booster system. The gas outlet pipe is continued from the one-way valve using plastic tubing for a few inches. This is to prevent an electrical connection between the stainless steel cylinder, which is connected to the positive side of the electrical supply, and the engine manifold, which is connected to the negative side of the electrical supply. If this pipe were metal all the way, then that would create a direct electrical short circuit. The pipe running to the engine intake manifold needs to be made of metal in the area near the engine due to the high engine temperature. So stainless steel pipe should be used for the last part of the gas supply pipe running to the engine. The gas supply pipe fitting is made to the most central of the bungs fitted to the manifold. This again is a really strong indicator of how similar the Nitro cell is to the Joe cell. The Joe cell has to avoid that same electrical short-circuiting by having at least some of the supply pipe to the engine being made of a non-conductive plastic pipe. For the initial testing period, a filling port with a screw cap is mounted at the top of the cylinder in order to allow the water inside to be topped up as necessary. Later on, if long journeys are made on a regular basis, then it is worth fitting a separate water tank, water level sensor and water injection system using a standard vehicle windscreen washer water pump. The topping up is done with water alone because a rock salt additive is added to the water inside the cylinder, but it does not get used in the process, and so it does not need to be replaced with these additional features. Then the gas generation cell, certainly the outer part of it, looks like this. So to recap, you have the negative side of the battery coming through to a 10mm diameter threaded stainless steel rod, which is an electrode running down the length of the cylinder. You have a 1/2 inch or 12mm gas outlet system, some part of which will have both a one-way valve and a length of plastic pipe. The filler cap is located on the outside, and the stainless steel bolt TIG welded to the outside of the cylinder is used to make the connection to the positive side of the battery. However, the negative electrode, which is the 10mm stainless steel threaded rod, needs to be augmented to give a larger operational surface area. There's one further step, and that is to add an inner cylinder of 316L grade stainless steel. This cylinder is 274mm, that's 10 3/4 inches long, and 80mm, which is 3.15 inches in diameter. Both cylinders have a wall thickness of 1mm. The inner cylinder is supported on the central threaded bar and is clamped in place with retaining nuts. A supporting lug is created by making 2 cuts at each end of the cylinder, drilling a hole and then bending the lug up inside the cylinder at right angles to its axis. So in other words, you're making a cut there and a cut parallel to that and drilling a hole for the metal bar, and you do that at both ends. You then fold the 2 tabs at right angles inwards. They're both drilled with a 10mm diameter hole. So the mounting lugs then are strips from the bottom of the cylinder facing upwards or bending upwards and supporting, well, you would say supporting the actual rod, but it's the other way around. The rod is supporting this inner cylinder. The inner cylinder is bolted with two nuts on each of the mounting lugs. The mounting lug is bent upwards, and then the bolts are used to connect it in. They're a little bit difficult to put in place if you don't think about it. The inner nuts are maneuvered on the inside of one of the lugs by hand, and then the threaded rod is rotated to move one nut to the inside of the other lug, while the nearer nut is held to prevent it rotating. When the rod is positioned correctly and the inner nuts, that is these two here, the ones on the inside of the two lugs, which are difficult to get at because this is a relatively narrow cylinder, they're pressed up hard against the lugs, even though the lugs aren't pushed out of position. Then you put the outer nuts onto the threaded rod and use a box spanner to lock the outer nuts tightly against the lugs, forming a strong mounting lock. Now that gives an electrical connection to the cylinder from the threaded rod. The inner cylinder is inserted inside the outer cylinder, and then the Lexan end discs are then added and the outer lock nuts put in position to produce this particular arrangement here. So you have the outer nuts and washer as before, and you have now inner nuts and an additional large surface area secondary cylinder inside the first one. There is, due to the dimensions picked, a 9mm gap between the outside of the inner cylinder and the inside of the outer cylinder. This gap, of course, goes right round 360 degrees around the cylinders. The inner cylinder is located 10mm clear of the Lexan end discs. This gives you a unit which is looks like this. Has water added to it. The interesting thing about Lexan is that it is transparent, and you can see through it to exactly how deep the water inside the cylinder actually is. So it controls the mechanism, or controls your view of what's happening as you put water into the outer cylinder itself. And it's completed then by winding one length of wire in a coil around the outside of the outer cylinder, and the battery positive then goes to the start of this outer wire, and the end of it goes to the connection to the outer cylinder. The reason why you're using plastic covered wire on the outside of the outer cylinder is because the outer cylinder would short circuit it all of the turns together, and you would lose the effect of having a coil if you did it that way. So you're using plastic covered, fairly heavy duty copper wire. It has a conductor diameter of 2mm for the core, that is the British standard wire gauge 14, or the American wire gauge 12 sized wire. The coil is held positioned at the ends of the cylinder with plastic cable ties, as these are non-magnetic. This coil is of major importance in this design, as the strong magnetic field produced by it has a very marked effect on the performance of the cell. The magnetic field produced by this coil increases the gas production by anything from 30% to 50%, and it increases the production of nitrogen hydroxide by a factor of 10 times. The electrical connection of the coil is in series with the cell, so the battery positive is not taken directly to the bolt welded to the outer cylinder, but instead it passes through the coil winding before being connected to the outer cylinder. We come now to the installation of the unit and its use. The gas outlet pipe is connected to a vacuum port directly below the carburetor on the manifold of the engine. This connection is important as the cell relies on the vacuum, actually reduced air pressure rather than vacuum, produced by the engine intake stroke as part of its gas forming process. The exact method of mounting the cell on a vehicle depends on the vehicle, so this is something which you need to work out for yourself. Be sure that you insulate the cell from the metal bodywork of the vehicle, and I would suggest that you keep it away from the high voltage electrical wiring, that is the coil, distributor, spark plug leads and so on. The electrical connection arrangement is shown here in this particular diagram. You have the battery connection here going to the chassis. The chassis, which is the battery minus, is connected on to the central rod of the device itself. The positive side of the battery goes through a 30 amp circuit breaker, but instead of going directly to the coil, in case there's ever any short circuit or accident in the operation of this thing, a relay is used. The relay is connected via the ignition switch so that the battery positive is only passed through to the nitro cell if the engine is running. So if you have the engine switched off, there is no power being passed to the nitro cell. But the connection then from the relay onwards is wrapped around the outside of the outer cylinder and then connected to the actual outer cylinder itself. And the gas output then is taken and passed on to the engine itself. In the case of larger engines where there are two cylinders, the connection arrangement is the same, but the two cylinders are wired in parallel with the same connection going to the same point on each of the cells. So the incoming gets connected to the start of the coil, and the incoming for the second one gets connected to the start of the coil. And that is the way that two of these cylinders are electrically connected. The method of electrical connection is important. It's vital that the electrical supply is disconnected when the engine's not running. For that reason, the power to the cells is taken via the vehicle's ignition switch, and in order not to load that switch unduly, a standard automotive relay is used to carry the main current, leaving just the relay current to be handled by the ignition switch. Also, a 30 amp circuit breaker or fuse is placed in the circuit immediately after the battery connection. In the unlikely event of some physical problem occurring with the unit itself, this device will disconnect the power instantly and avoid any possibility of a short circuit causing a fire or of excessive gas being produced when it's not needed. The water to be used in this cell needs to be selected carefully. Again, this parallels the operation of a Joe cell. Tap water is not acceptable as it will be contaminated with several additives, fluorine, chlorine and so on, put in it when going through the so-called purification process of the supply company, and many other chemicals are also picked up along the way. It's considered very important that the water be taken from a stream, preferably from where the stream rises, as that is the point of greatest purity. May I also suggest that the water be transported in either glass containers or stainless steel containers, as these help to maintain the purity. Avoid plastic containers because while these appear to be completely inert, they frequently are most definitely not inert, and chemicals from their manufacture can and do enter any liquid contained in them. The cell is filled to a depth of 25 millimeters or 1 inch below the top of the outer cylinder, and then on the first occasion only 1 or literally 2 grains of rock salt are added to the cell. This addition needs to be minimal as it controls the current draw from the electrical system and the strength of the magnetic field created by that current. After using the cell for at least a week, if the gas rate is not adequate, then add 1 more grain of rock salt. That is 1 and only 1 more grain. Getting the cell attuned to the vehicle is likely to take at least a week of use. Again, that's exactly the same as a Joe cell. The nitro cell is put in place and the vehicle run using its normal fuel. The needle valve on the cell's air intake is kept completely closed during the period. The inventor opted to continue running his engine on very small amounts of petrol plus this new gas fuel, the result being 3,000 miles covered on just 2 gallons of petrol. If you consider this still being a petrol-powered vehicle, then getting 1,500 miles per gallon is quite an achievement, and I would certainly settle for that. When the cell is first connected, you will notice that the engine takes over faster and tends to rev more than it did before. It will take several days for the system to settle down. Part of this is believed to be the effect of the new magnetic coil in the engine compartment. It may be that the metal parts of the vehicle have to take up a magnetic alignment which matches the magnetic field produced by the cell. Whether that's so or not, it will take a few days before the system settles down into its final state. It should be realized that if the vehicle has a fuel-controlled computer with an oxygen sensor mounted in the exhaust system, then the oxygen sensor signal will need to be adjusted. The www.freeenergyinfo.com/chapter10.pdf document shows in detail how to do this should it be necessary. If the vehicle has a carburetor, then there's an advantage in fitting a 1-inch bore carburetor of the type found on lawnmowers, as this promotes lower pressure inside the manifold and promotes good cell operation, as the lower the pressure, or the greater the so-called vacuum, the higher becomes the rate of gas production. We come now to practical details. The original end pieces were cut and grooved using a lathe. Most people do not own or have access to a lathe, so an alternative method of cutting the discs needs to be used. The essential part of this operation is to cut an accurate groove to take the 100 mm stainless steel outer cylinder. The groove needs to be cut accurately, as it needs to form an airtight seal on the end of the cylinder. Consequently, the end of the cylinder and the bottom of the groove both need to be straight and true if they are to mate securely. An alternative method is to use an adjustable hole cutter drill attachment. If this is used with a drill press or a vertical stand adapter for an electric hand drill, then if care is taken, an accurate groove of the correct dimensions can be cut. As an extra precaution, a thin layer of marine grade white Sikaflex 291 bedding compound can be used in the bottom of the groove. Two things here. Firstly, only use the genuine Sikaflex 291 compound, even though it's far more expensive than other products which claim to be equivalents. They aren't, so pay for the genuine product. Secondly, we do not want the slightest trace of the Sikaflex contacting the electrolyte, if we can possibly avoid it, so be very sparing in the amount put into the groove, no matter what you paid for it. Make sure that the bedding compound is placed only in the very bottom of the groove and not on the sides. When the cylinder is forced into the groove, a very small amount of the compound will be driven into any gap between the cylinder and the sides of the groove. What is needed is a result that looks like this. This is the groove in the end cap, and the slot is only 1 millimeter wide, and it's only 3 millimeters deep. The layer of Sikaflex 291 bedding compound is a very small layer, less than a millimeter deep. This is the end cap, and the groove cut in it is shown larger here. The other important part of this joint is the end of the outer cylinder. It's recommended that the cylinder be cut by hand with a hacksaw to avoid generating excessive heat which can affect the structure of the metal. To get the end exactly square, use a piece of printer paper. This has straight edges and square corners, so wrap it flat around the cylinder and maneuver it into place so that the overlapping edges match exactly on both sides. If the paper is flat and tight against the cylinder and the edges match exactly, then the edge of the paper will be an exact, true and square line around the cylinder. Mark along the edge of the paper with a felt pen and then use that line as a guide to a perfectly square cut. To avoid excessive heat, do not use any power tool like an angle grinder on the cylinder. Just clean the edges of the cut gently with a hand file. In the diagram shown earlier, the gas pipe, water filler cap and the battery positive connection bolt have all been shown on the top of the cylinder. This is only to show them clearly, and there's no need to have them positioned like that. You will notice that they all get in the way of the wire coil, which is not an advantage. It is necessary for the gas pipe to be positioned at the top, as that gives the best clearance above the water surface. Clearance should be maintained at 1 inch, that is 25 millimeters. The water filler cap, which was shown on the top of the cylinder, will be better positioned on one of the end caps, as that would keep it out of the way of the coil of wire. So the end cap has a hole drilled in it to take the water filler. This arrangement has the advantage that it doesn't require a filler hole to be drilled through the steel cylinder. Drilling holes in steel is not that simple, especially if you're trying to do it in a cylinder. It's necessary for the electrical connection to be welded to the cylinder, but it's not necessary to have a head on the bolt, as that just gets in the way of the electrical coil. The best strategy is to use a longer bolt of small diameter and remove the head and weld the shaft of the bolt in place with spot welds, which will not get in the way of the coil. That's as shown in this diagram here. You have the spot weld on one side of the actual bolt, and you have a spot weld on the other side of the bolt, and that avoids creating a very large space in the coil that's been wound around the cylinder itself. In other words, the weld is very small, about the same diameter as the bolt, and everything else is clear of the actual wire coil. So that is the best way to deal with that particular connection. The bolt is kept just clear of the end cap to avoid fouling it when it's clamped onto the cylinder. A lock nut is used to keep the solder tag assembly clear of the outer edge of the end cap, in other words, so that you've got a gap there. So the steel bolt can be welded very close indeed to the end cap, and by using two bolts underneath and one on top, you can arrange the connection of the battery positive to the actual bolt without getting in the way of the coil. That's the neat way of doing it. It's important that once connected, the electrical connections to the coil are maintained ever afterwards to ensure that the magnetic field stays in the same direction. Remember that the surrounding metal parts of the vehicle will take up a magnetic orientation matching that of the coil's magnetic field, so you do not want to keep changing the direction of that magnetic field. When welding a bolt to the outer cylinder, be sure to use stainless steel TIG wire. The TIG welder, TIG welder, needs to be the sort of equipment used for making the weld. MIG do not weld TIG wire properly. If you don't have one, then you can hire one. If you can't hire one, then your local metal fabrication shop will make the spot welds for you in less than a minute, and they probably won't charge you for doing them because it's such a tiny job for them, and the nuisance value of creating paperwork outbalances any income that they will get from it, and it's waste time doing paperwork anyway. People who weld things in steel tend to be very practical people, and they don't bother very much with the technicalities of paperwork. The grade of stainless steel in the cylinders is important. Grade 316L is nearly non-magnetic, so if you hold the cylinder with the sides vertical and place a magnet against the cylinder, the magnet should fall off under its own weight. Try this test no matter what grade the stainless steel is supposed to be, as some steels are not labeled correctly. There is a good chance that you will be able to find suitable tubing at your local scrapyard, but be careful on sizing. The 9mm gap between the outer 100mm diameter cylinder and the inner cylinder's 80mm diameter is very important. That 9mm gap is important. The gap needs to be 9mm, which is 11/32 of an inch, so it's really necessary to vary the diameter slightly up or down if it is for any reason necessary to change it. Be sure to pick material which gives the correct 9mm gap between the cylinders. Seamless piping is usually preferred to pipes which have seams, as the seam welding tends to generate a magnetic effect in the steel. However, if a seam pipe passes the magnet test with the magnet falling off, it's definitely good material for the cell. If you can get it, a good material for the 12mm half-inch pipe running to the carburetor manifold is aluminium. Please remember that the one-way valve on the cell's output pipe needs to be connected to this pipe with a material which insulates the two metal components. The suggested piping does talk about aluminium. Personally, I don't think aluminium is a great idea for a connection like that. You really need stainless steel pipe. Aluminium has a strong negative magnetic effect. I know magnets don't stick under their own weight to aluminium, or aluminum as Americans put it. The situation though is that there is a very strong damping effect to magnetic fields, in spite of the fact that magnets don't stick to the actual aluminium itself. Please remember that it's very important indeed to have at least one section of plastic between the nitro cell and the connection physically to the engine. The plastic pipe is essential to avoid a short circuit, as I mentioned before. And please remember also to insulate the cell from the vehicle chassis and components to avoid a different style of short circuit. An alternative to using the rather expensive Lexan for the end caps is to use UHMWP, which is ultra high molecular weight polythene, which is cheap, easy to maintain, easy to obtain as plastic food chopping boards. The advantage of Lexan, though, is that it is transparent, and so the level of electrolyte can be seen without the need for removing the water filler cap. It has been suggested that the topping up of water in the cell can be automatic if you wish it to be so. For this, a water level sensor circuit is used to drive a standard windscreen washer water pump when the level of the electrolyte falls below the design level. The sensor itself can be a bolt running through one of the end caps as shown here. This is the arrangement here. You have a circuit board, and the sensor part of the circuit board goes to the upper bolt here. A connection is made through the electrolyte to the actual electrode itself and back through to the control circuit. That means that if the electrolyte level falls so it no longer touches this particular upper bolt, then the resistance level between the two wires will go up enormously, and the circuit operates on that. When the water level drops too low, it then powers up the water pump, which pumps water from the water tank straight into the electrolyte container until the water level rises and touches the upper bolt again. You can make this circuit up yourself quite easily. Suitable circuitry is shown in the chapter 12 PDF at the free-energy-info.com website, and there's no reason why you should not design and build your own circuit for this. Mind you, in passing, there are circuits in chapter 10 which do this function for you, but it's easy to design your own circuit if you wish. In the initial stages of testing and installation, when adding rock salt, be very sparing indeed. Add just 1 grain at a time, because the salt ions are very effective in carrying current through the electrolyte solution. Also, if too much is added, it's difficult to reduce the concentration, as more water needs to be added, which involves draining off some of the water already in the cell. It's much easier to take your time and add very, very little salt. Give the salt grain plenty of time to dissolve and spread out throughout the electrolyte before checking the cell performance again. Let me remind you that during the initial cell testing, the air intake needle valve is closed completely, and it's not eased open until the engine is running satisfactorily. In the engine acclimatization period, the engine should be run on its normal fuel and the cell just used as a booster. Remember that it will take at least a week for the vehicle to settle down to its new method of operation. There's no particular hurry, so take your time and don't rush things. If the vehicle is fitted with a computer control of the fuel supply, it may be necessary to apply some control to the unit by adjusting the signal coming from the oxygen sensor placed in the vehicle's exhausts. The information on how to do this is shown in considerable detail in chapter 10 of the ebook, which is available as a free download from any of my websites. Some questions have been asked about the cell. The first one: does petrol have to be used, or can the engine be run on the cell alone? The answer is no. You can eventually eliminate petrol altogether, but the engine runs so cleanly that old carbon deposits around the piston rings and elsewhere will get cleaned away and the components may rust. These parts can eventually be replaced with stainless steel versions, or instead of that, it is probably possible to avoid replacements by the use of the oil additive called this word, which is VACCLAISOCRYPTENE, and you're welcome to pronounce that word yourself. But that word, QX, and molybdenum disulfide can be got from the clickspokane.com site. You can go there for details as well. The additive reduces wear to such a degree that engine life may be doubled, no matter what fuel has been used. Question 2. Why is 3 millimeters the length of a unit? The answer is just for convenience in fitting into the engine compartment. It can easily be longer if space allows it. The longer the unit, the greater the gas production, and that is why two 300mm cells are needed for engines over 2 liters in capacity. Question 3. Does the cell body need to be made from seamless pipe? The answer is seamless 316L grade stainless steel is preferable. Not essential, but is preferable. Question 4. How do you determine the amount of rock salt to add to the water in the cell? The answer is the amount varies with the type and size of engine be dealt with. You want the minimum current through the coil, so start with 1 grain and increase it only very gradually with tiny amounts. If the cell has been mounted in the engine compartment of a vehicle, then the make, model and size of the vehicle will affect the amount due to the magnetic field effect of metal components near the cell. Question 5. Does it matter which end of the coil is connected to the outer electrode, to the outer cylinder, I should say? The answer is no, it can be either end. In other words, it doesn't matter which direction the current flows through the coil around the cell, but whatever direction is used, stick to that one and don't keep changing the direction. Question 6. Is the pipe diameter shown from the cell to the engine the best size? The answer is the half-inch diameter is very good, as it increases the vacuum inside the cell as the engine runs. When first testing the engine, remember that the needle valve is completely shut off, and when it is open during tuning, it is only open to a minimal setting. Question 7. Are the exhaust emissions damaging to the environment? The answer: some years ago a Mercedes car dealer ran his own emissions test on a new Mercedes diesel using his own equipment. He found that the emissions were reduced by 50% and the engine power increased by 12%. The engine ran better, cleaner and quieter. He was fired for doing that. Other independent gas analyzer tests showed that there is an increase in water emissions and a drop in carbon emissions as less fossil fuel is used. It was also noted that the volume of gas produced by the cell was affected by where it was mounted in the engine compartment. This is thought to be due to the magnetic effect of the engine compartment on the cell. However, having emphasized these concerns and provisos, I was informed early in the year 2010 that Jim Bundock in the UK has had considerable success using this design as a booster. He estimates that using this device has saved him about £500 in fuel costs over a 2-year period. Here is some detail from him. These are 2 of his cells, one without a coil, one with a coil. They were used in 2 different vehicles for more than a year. The vehicles are Ford Transit vans with a 2.5 litre diesel engine. One is 16 years old and the other is 17 years old, and the Nitro cells have given a 10 miles per gallon improvement from the day that they were installed, in spite of the vans being heavily loaded when being used. The original miles per gallon was 25, so the resulting 35 miles per gallon represents a 40% improvement over a long period. Jim says that these cells were built from the plans shown above, the only variation being that instead of bending the tabs for the inner tubes, tabs were silver soldered at the ends of the inner tubes, as shown in this photograph here. This is the end of one of Jim Bundock's inner tubes. These cells are, in Jim's case, are run without salt at all, and they work equally well without the wire wrap suggested in the design. The vehicle cell is 18 inches tall and 4 inches in diameter, and it has a rubber diaphragm on the top which acts both as a seal and as an anti-slosh device. The inner cell gives a 9mm gap between the inner and outer cylinders. The cell ends and spacers are made from plastic food chopping board. The top spacers are about 30mm long, and it was found that vibration tended to dislodge shorter ones. The vertical slow cell is very easy to install. On one of the fast horizontal units there is a length of blue pipe. There's the actual pipe there. This prevents water from entering the engine when a certain boy racer tries to negotiate corners at the speed of light. The horizontal cell was plumbed in using a plastic 12mm pipe connected to the inlet manifold. Personally, I don't think these cells like speed, and they seem to respond best when driving around 50 miles an hour. This is for a single cell on a diesel engine. The cell is wired in as a standard only on a diesel. The relay is connected to the fuel cut-off valve, making it very easy to wire, and when the engine is switched off, then the cell is turned off at the same time. Using a miniature version of the upright cell, the borehole water filler which I use is pre-charged, he says, and it's pre-charged on the bench for as long as I feel it needs to be, just to remove some of the material suspended in it. Topping up with water is done every 750 miles or so, and it takes about an eggful cup of water. All in all, the Nitro cell is a good, honest working device. It is a simple drive and go piece of kit that has saved me around £500 in 2 years, and will continue doing that forever.